involutes. Involute of a polygon, involute of a circle, involute of a straight line. So these are very, very important in the involute. So first of all, what do you mean by an involute and how to draw the involute of a polygon or a circle? So we can see in this today's class. So first of all, what do you mean? Involute means, involute is a single curved line traced out by an end of a string. So it is a single curved line traced out by an end of a string when unwounded itself from a straight line or a circle or a polygon. The string being always kept tight. So involute is a single curved line traced out by an end of a string when unwounded itself from a straight line or a polygon or a circle. The string, so here the string being always kept tight. So this is the involute of a circle or involute of a polygon. So I am going to discuss about with some examples. So first one is, construct an involute of a pentagon of 25 mm side and also draw a tangent and normal at any point on the curve. But here in our problem they are not giving the string length. So here we can assuming that the string length is which is equal to the circumference of the pentagon. That means the perimeter of the pentagon is nothing but the here string length in our problem. So here for constructing the involute of a circle or involute of a pentagon or involute of a any polygon, so we have three cases is there. If the string length is which is equal to the perimeter, and next case is the string length is greater than the perimeter, and another case is string length is less than the perimeter. How we will draw the involute of that polygon and a circle? So we are discussing in this class. So first of all, here they are not giving the string length, so we can assuming that the perimeter of that pentagon is as a string length. So first of all, we will draw a pentagon by using any method. By using our exterior angle method or interior angle method, we will construct a pentagon first of all. Construct a pentagon with the length of 25 mm side. So by taking the length of 25 mm, we will construct a pentagon. I am taking the length of the pentagon should be 25. And now with an angle of 72 degrees, so we will construct a pentagon. First of all, I am drawing a side. After drawing a side, so we will construct a pentagon. 4 to 5 is one of the side here. After constructing that side, by making an angle of 72, we can follow with an angle of 72 here also. We will draw the 25 mm side. Next, from this also we can take the 72 degrees angle. From all the corners you can take the 72 degrees and we will construct a pentagon. In this angle, we will draw a side with another 25 and joining these two sides. Give the naming for this pentagon as 1, 2, 3, 4, 5 like that. So I am giving here 1, this is 2 and this is 3 like that. So after that, so from the point 5 we will draw the length of the string. So the length of the string, so the length of the pentagon, we will draw a length of the string. So the length of the string is we can take as the perimeter of the pentagon. Perimeter of the pentagon is nothing but, so pentagon is nothing but 5 into side of the pentagon. So perimeter P is nothing but the 5 into n into number of sides. n into side of the required polygon. So 5 into here 25. So we'll get the perimeter of the pentagon should be 125 mm. So with the 125 mm length, we will draw a length of the string with 125 mm. I am taking this point as point P. And now we can divide this string length into 5 parts because the pentagon having 5 sides. So the string length is also divided into 5 parts. So by taking each part should be 25 mm. So you can divide it. 1, 2, 3, 4 and this is 5. Now after dividing the string of the length into 5 parts, that means 125 into 5 parts. Now from the point, from all the sides, that means from 5, 1, 1, 2, 2, 3 and 3, 4 and 4, 5, we'll draw the extension lines. Producing the lines from 5, 1, similarly 1 to 2, we'll producing the lines like that. Similarly from 2 to 3, producing the lines in this direction. From 3 to 4 also producing the lines. Similarly 4 to 5, if you producing the lines, so we'll get the line, horizontal line like that. Now by taking the length of 1 to P, by taking the length of 1 to 1P, with the length of 1P, 1 as the center, draw the arc. Draw the arc from point 1 as the center, draw a arc like that. Similarly 2P as the radii, 2P as the radii, 2 as the center, draw the another arc. Draw the arcs biggerly. 3 as the center, 3 as the center, 3P as the radii, 3P as the radii, 3 as the center. Draw the another arc. Next 4 as the center, 4P as the radii, 4P as the radii, 4 as the center. Draw the arc like that. Now we will get the different points. So 5 and 5P. So at 5 we will get the another point. So in locating different points, P1 here, P2 here, this is point P3, this is point P4. So at 5 we will get the P5. Now through the point P, joining all the points by using your free hand. So we will draw a neat curve freehandly. Free-handedly while joining, free-handedly we will draw a curve. Or by using your French curves also we will draw the curves like that. Now make it thick. So this is our involute curve. So this curve represents about the involute of a pentagon. So like that we will draw the involute. After drawing the involute curve, so we will draw the tangent and normal. So here just you can bisecting the angle. So here I am taking the angle P1, P5, P. So this angle should be 72. So I am taking the half of that 72. Half of the 72 angle. I am taking this angle should be, total angle should be 72, this angle should be, so I am taking the half of that angle. Through this angle we will draw the tangent and normal. This is our normal, and through this point we will draw the tangent. This is our tangent, like that. We will draw the tangent and normal. So this is our normal, make it as NM. This is our tangent, T dash, like that. So just we can bisecting the angle. That means you can bisecting the angle. That means total angle should be here. Angle P1, P5, P is 72. You can bisecting, that means take the midpoint of that angle. That means 36 degrees you can choose, and we will draw the normal line. And through that line, NM line, we will draw a perpendicular bisector and we will obtain the tangent. So this is the construction of involute of a pentagon if the length of the side which is equal to the perimeter of a pentagon. Means draw the curve traced out by an end of a thin wire unwound from a regular hexagon of side 20 mm. The wire is being kept tight. Draw a tangent and normal to the curve at a point 90 mm from the center of the hexagon. So here the type of the polygon is, they are giving that hexagon, and they are asking that a thin wire unwounded from a regular hexagon of side of the hexagon should be 20 mm. They are giving that, and they are asking that draw the involute of that hexagon and also draw the tangent and normal. So they are giving the side of the side S is equal to 20 mm of the hexagon. So first of all we will find out the perimeter of that hexagon. So 20 into 6, so we will get 120 mm. So this is the length of the string is here. The length of the string is which is equal to 120 mm in this case. So first of all in this method, so we will construct a hexagon first of all with the side following all the sides should be 20 mm. By following all the sides should be 20. So and by using the exterior angle method, we know that exterior angle of a hexagon should be 60 degrees. By taking each angle should be 60. Each angle should be, you can take 60, and we will construct a hexagon. Similarly, from this end also, we will making an angle of 60. From this end also, making an angle of 60. From all the corners you can take 60 degrees. By using the exterior angle method, we will construct the hexagon initially. Like that we will construct a hexagon. So after constructing the hexagon, give the point naming 1, 2, 3, 4, 5 and 6. Now we will draw the length of the string as the perimeter of the hexagon. You can take perimeter of the hexagon, that should be 120. So take perimeter 120. So locate point P. So here 6P is nothing but the length of the string, that is equal to 120. Now we can divide the string length into 6 parts because they are giving a hexagon. So we can divide this one into 6 parts. Suppose if it is a octagon, we can divide this one into 8 parts. Like that. Give the naming here 1, 2, 3, 4, 5 and 6. Now extend it from the all the sides. You can draw the producing the lines, 6 to 1 line producing like that, 1 to line, 1 to 2 producing 1 to 2 line, producing 2 to 3 line, producing 3 to 4 line, in this manner producing 4 to 5 line. If you producing 5 to 6 line, you will get the horizontal line. Now you can follow the same procedure. Measure the length of 1 to P. Take the length of 1 to P. 1 as the center, draw the arc. Similarly, measure the length of 2 to P. 2 to P as the radii, 2 as the center. Draw the arc. Similarly, 3 to P as the radii, 3P as the radii, 3 as the center. Draw the arc. Next, 4 as the center, 4P as the radii, 4. This 4 is the center, 4P as the radii, draw the arc. Next 5 as the center, 5P as the radii, draw the arc. At point 6 we will get the another point. So here we will get point P1, point P2, point P3, point P4. This is point P5. At point 6 we will get the point P6. Now we will join in all the points. By freehandly we will draw a curve. Freehandedly, by using your freehandedly we will draw a curve, joining all the points. Now by using your HB pencil, make it thick. Make it thick. So this is the involute of a hexagon. If the length of the string is which is equal to the perimeter of a hexagon, so we will draw the involute like that. We will follow this procedure like that. So this is the involute. So here the type of the polygon is also thick. You can representing the polygon is also thick. That means the hexagon should be also you can drawn by using your HB pencil. In previous diagram the pentagon is also should be thick. So after constructing this one, so they are asking that here draw a tangent and normal. So how to draw the tangent and normal? For drawing the tangent and normal, so first of all I am locating the center point. Just we can joining or we can measuring the length of 1 to 4, or we can joining 3 to 6. Lightly we can joining 2 to 5 and also 1 to 4. We will get the midpoint of the hexagon. So this is the midpoint. So they are giving that from the midpoint, they are giving that the distance we can follow, draw a tangent and normal to the curve at a point 90 mm from the center of the hexagon. From the center of the hexagon you can take 90 mm. So I am taking 90 mm distance. From the center I am taking 90 mm and I am drawing a tangent. I am drawing an arc. Drawing an arc on the involute like that. And I am locating here. This point is I am locating point P, or I am locating P1. or I am locating PA, or I am locating T point. Now joining the center and that line, joining the center of this hexagon and the point T. Join the center and the point T. So if you see that this point T is very nearer to P2, so we can find out whether the point is very nearest to which point. So point P2. So the point P2 can be drawn from the point 2. So take 2 as from 2, joining 2 and T and extended this line. So from point 2 we will draw the normal line like that through the direction of 2 and T, because the point T is nearer to point P2. So the point P2 can be drawn from the point 2. So 2 to T. So in the direction of 2 to T we will draw the normal line, and by making an angle of 90 degrees in this direction we will draw the tangent. So this is our required problem for constructing an involute of a hexagon. So after that we will draw the dimensioning also. Give the dimensioning. They are giving that this side length is 20, and also this radius is also they are giving that. This is R90. Like that we will draw the curve. So this is our required problem. This is problem number 3. A string of length 108 mm is wound around a pentagon of 20 mm side. Draw the path traced out by the end of the string. So first of all, here also they are clearly giving that the string of the length is 108 mm. Wound around a pentagon of 20 mm side. So if you observe that here, if you find out the perimeter of that pentagon, so we will get 5 into 20, that is equal to 100 mm. So the perimeter of the pentagon which is less than the length of the string. So here, if the perimeter of the pentagon is less than the length of the string, so how we will draw the pentagon, how we will draw the involute? So we can see here. So here this is the important case. The length of the string is here greater than the perimeter. In this case, how we will draw the perimeter of the, how we will draw the involute of that pentagon? So that is very important. So before that, so here also in this method also, first of all we will construct a pentagon with a 20 mm side by following the exterior angle method, by taking the each angle should be 72 degrees. Each angle we can follow 72. Constructing of a polygon should be very important. We can follow the exterior angle method and we will construct the pentagon initially. So after constructing the pentagon, I am giving the naming here 1, 2, 3, 4 and 5. So after drawing the pentagon, we will draw the length of the string. So first of all we will draw the perimeter. So what is the perimeter of the pentagon? Should be 100. So from the point 5, we will draw the 100 mm length of the string. 100 mm. 5 to 5, and you can divide it this length into 5 parts by taking each side should be 20. But they are giving that the length of the string is 108, so you can extend it this length into another 8 mm. You can extend it this length, extending this length and locating point P. So they are giving that this length. So the length of the string, total length of the string should be 5 pieces, that is equal to the length of the string here. So first of all, we will draw the perimeter line length and divided that perimeter should be 5 parts. After that, so they are giving that the length of the string is 100. So we can extend it another 8 mm because the perimeter should be 100. So we can add 8 mm and we can locating point P. Now extending all the sides, 5 to 1 we can extend it. That means you can producing the 5 to 1 line and 1 to 2 line, similarly 2 to 3 line, extending 2 to 3 line, similarly 3 to 4 line extended, similarly 4 to 5, if you extend it, we will get the like that. Now measuring that, so in this problem you can take measure 1p line length, 1p radius, 1 as the center, draw the arc. 1p radius, 1 as the center, draw the arc, larger arc. 2p radius you can follow, 2 as the center, draw the arc. Similarly 3p center, 3p radii, 3 center, 3p radii, draw the arc. Next 4p radii, 4 center, draw the arc. Similarly 5 center, 5p radii, draw the arc. Very small length, you can draw the arc like that. Now we are locating the different points. So here P1, P2, P3, P4. So here we'll get the P5 point and here we'll get the P point. Okay, like that. So joining all the points with freehandedly we will joining all the points. So if the length of the string is equal to the perimeter of the polygon or a perimeter of a circle, we will get exactly at the, so here Pentagon, so exactly at 5 we will get around the circumference we will get the involute. But here the length of the string is greater than the perimeter, so the involute is we will get like that. So now we will joining all the points. Freehand sketching. We will draw the freehand freehand sketch. So this is our required card. After that, the polygon should be also, you can make it, polygon should be also thick. So when the perimeter of a pentagon is less than the length of the string, we will get the curve, involute curve like that. We can extending the involute. So suppose if it is equal at the 0.5, we will get the involute. So the length of the string is greater than, so we will get the involute like that. Suppose if the length of the string is less less than the perimeter, so before 0.5 we will get the involute. So you can see that problem also we can see. So this 20, and you can take what is this distance they are clearly giving in our problem. So I am taking this distance is perimeter of the pentagon and this distance is length of the string. So this is 100 and this is 108. So this is the construction of a ellipse, the construction of a pentagon. So if the length of the string is less than the perimeter of a polygon, suppose if the perimeter is greater than the length of the string, in this case how we will draw the involute of a polygon, involute of a polygon or involute of a circle, how we will draw the involute of a pentagon. So here they are giving that a string of the length is 110 mm is wound around a pentagon of 25 mm side. Draw the path traced out by the end of the string. So if you observe that, if you find out the perimeter of the pentagon 5 into 25, that is equal to 125 mm. So the perimeter of the pentagon should be greater than the length of the string here. In this condition, how we will draw the pentagon, how we will draw the involute. So we can see. So first of all, we will construct a pentagon with the 25 mm side. 25 mm side length, and by following the exterior angle method, by taking each angle should be 72. From all the corners you can take 72 and we will construct a pentagon. So this method is very, very important. Constructing of a polygon. Now from this corner also you can take 72. After drawing a pentagon, give the naming here. After drawing the pentagon with the length of the strings, they are giving that 110 mm. So with the perimeter of the pentagon 125, we will draw a horizontal line. 125 mm length you can follow. After drawing the length of the string, so perimeter of the pentagon, we will divide that perimeter into 5 parts. By taking each part should be 25. But they are giving the length of the string is 110 mm. So I am representing the length of the string from the point 5. I am taking 110 mm and locating point P. So this is 5P represent the length of the string here. 5 to 5 represent the perimeter of the pentagon. Now you can follow the procedure. Now joining, extending 5 to 1 line, 1 to 2 line, producing like that, 2 to 3 line, producing 2 to 3 line, producing 3 to 4 line, and producing 4 to 5 line like that. So after producing this line, measure the line length of 1 to P. 1 2p you can follow. Take 1 as the center, draw the arc. Similarly, measure 2 2p. Measure 2 2p. 2 as the center, draw the arc. Just you can draw the large arc. 3 2p line length, measure 3 as the center, draw the arc. Similarly, 4 2p as the radii, 4 as the center, draw the arc up to the polygon. So we'll get the point here. So here we'll get point P, P1, P2, P3. This is point P4, and here we'll get point P5, or we'll get P point. Now we'll joining all the points and we'll obtain a freehand sketching. We will draw in freehand sketching and we'll obtain a involute of a pentagon. So if the perimeter of the joining neatly, get the curve like that. If the length of the string is less than the perimeter of a polygon, we will get the involute curve like that. So here after drawing the total diagram, we will mention the dimensions also. This length is 25 side of the polygon. So length of the string is, they are giving that 110, and this length is perimeter, that is equal to 125. So like that we will draw a involute when the length of the string is equal to perimeter and the length of the string is greater than the perimeter of a polygon, and the length of the string is less than the perimeter of a polygon. We will draw the involutes like that. Giving that involute of a circle, draw the involute of a circle of diameter 50 mm. Also draw a tangent and normal at a point 100 mm from the center of the circle. So how we will draw the involute of a polygon? So here also you can follow the same procedure, but this is different one. So first of all, they are giving the circle diameter is 50 mm. So you can take the radius of the circle. So take the radius of the circle is 25 mm. You can take 25 mm radius, and we will draw a circle first of all initially. After drawing the circle, locating the center point and divided this circle into 12 parts. I am dividing the circle into 12 parts. By taking each angle should be 30 degrees and divide the circle into 12 parts. Divide the circle into 12 parts. Now after dividing the circle, so we'll give the naming here 12. This is 1, 2, 3, 4, 5, 6. Give the naming like that. Now with the length of the perimeter or find the circumference of the circle here. Circumference of the circle is find out 5d by using the formula 5d, that is 22 by 7 into pi d. D is nothing but here 50. So we will get 157.07 millimeters. So approximately we will get 157 mm. So with the perimeter of that circle, so we will draw a length from point 12, taking the 12 as the fixed point. So with 157 mm, we will draw a length of the string horizontally, 157 mm length. I am locating this point as P point. So 12P is nothing but the perimeter of the circle. And now divided this 12P line into 12 parts. Because the circle is divided into 12 parts, so here the circumference of that line, the perimeter of that line 12P is also divided into 12 parts. So for that we are following a divide a line method. So from point 12, making an angle of taking less than 45 or greater than 50, choose any one angle and we will draw an inclined line from point 12 like that. And now by using your compass, take any length and we will divide that inclination line into 12 parts. Dividing a line, you can follow. After dividing this inclination line into 12 parts, joining 12 and P line. Joining 12 and P. Through 12 dash and P, we will draw the parallel lines from the points. We will draw the parallel lines. Draw the parallel lines up to the circumference of that 12P line. From all the points, draw the parallel lines to 12 dash and P. By using your mini drafter, the drawing of these lines are very easy. Now we are locating different points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now we will draw the tangential lines from the points on the circle. We will draw the tangential lines by making an angle of 90 degrees. So from O1, from point 1 through this direction, we will draw the tangential line. By using one mini drafter, draw these lines very easily like that. Similarly from O2, draw the tangential line with an angle of 90 degrees. Similarly O3, draw the tangential line. All the tangential lines should be drawn with an angle of 90 degrees. From O6, from O7 also we will draw the tangential line. From O8, from O9, from O10, similarly from O11, Draw the tangential lines. So these are the tangential lines. Like that we will draw the tangential line. After drawing the tangential lines from the points on the circle, now you can follow the procedure. Measure the line length of 1 to P. Length of 1 to P. From point 1, draw the arc. Similarly, measure the length of 2 to P. Measure 2 to P line length. 2 as the center, draw the arc. Similarly, measure 3 to P. 3 to P as the radii. 3 as the center, draw the arc. 4P as the radii. 4 as the center, draw the arc. 5P, measure 5P line length. 5 as the center, draw the arc. 6P, measure 6P line length. 6 as the center, draw the arc. 7P line length, measure 7 as the center, draw the arc. 8P, measure 8 as the center, draw the arc. 9P, measure 9P line length. 9 as the center, draw the arc. Measure 10P line length. Draw the arc. 10 as the center. 11P, measure 11 as the center, draw the arc. At the point 12 we will get the point. So locating different points P1, P2, P3, point P4, P5, point P6, P7, P8, P9 point, P10 point, P11 and P12. At point 12 we will get the P12. So joining all the points with freehand, free-handedly joining all the points. We will get an involute of a circle. So this is the method of constructing a involute of a circle. So for dividing the circle into 8 parts also we will draw the involute. So this is the involute of a circle. The circle is also make it thick. So after drawing the involute of a circle, draw the dimensioning. So they are giving that this dimension. This dimension is 50 diameter. And this length is also well representing. So this is pi d, and this length should, the diameter should be, I am representing here 550. So like that we will draw the involute of a circle. So for drawing the involute of a circle, first of all we will draw a circle and divide the circle into 12 parts, and from the fixed point 12 we will draw the horizontal line with the perimeter of the circle or with the circumference of the circle, that is pi d. We will get 157 mm. So draw a horizontal line with 157 mm and divide that horizontal line into 12 parts. By following divide a line method, from point 12 we will draw an inclined line by taking an angle less than 45 and greater than 30, greater than 15. You can take any angle and we will draw inclined line and divided that inclined line into 12 parts, and joining 12 dash and P line through the 12 dash and P from the points on the inclined line, we will draw the parallel lines and locating different points 1, 2, 3, 4 up to 12 on the horizontal line. Now measure, and now from the points on the circle we will draw the tangential line from point O1, from O2, O3, O4 up to O12. We will draw the tangential lines by making an angle of 90 degrees. After drawing the tangential lines, measure the line length of 1 to P, 1 center, draw the arc. 2 to P, measure 2 at the center, draw the arc and locate point P2. 3 center, 3 P radii, 3 center, 3 P radii, draw the arc and locate point P3. Like that, we can follow the same procedure and locate different points P4, P5, P6 up to P12. And so by using our free hand, so we will draw a neat curve and we will obtain the involute of a circle. So this is the involute of a circle. So here in this problem they are giving that an inelastic string of length 100 mm is wound around a circle of 26 mm diameter. Draw the path traced out by the end of the string or spring. So here if you find out the perimeter pi d, that is equal to 22 by 7 into 26. So how much we will get? 22 by 7 into 26. So 22 by 7 into 26, around we will get 7 3s. 3.71 into 22. So we will get around 82 mm. So if you observe that here, the perimeter or the circumference of the circle, so which is the circumference of the circle is here less than the length of the string here. So in this case, how we will draw the diagram? So the length of the string is here, the length of the string is less than the perimeter, the length of the string is greater than the perimeter of the circle. How we will draw the problem? Here we can see. So first of all, initially with the diameter 26 mm, so we will construct a circle. So diameter 26, so we can take Take 13 mm radius and we will draw a circle. So after drawing a circle, I am dividing this circle into 12 parts, or you can divide it 8 parts. So I am dividing here 8 parts. Okay, I am dividing 8 parts. For dividing the circle into 8 parts, so you can choose the angle should be, you can follow 45 degrees. So by making an angle of 45 degrees from the center, so you can take the angle should be 45. Divide the circle into 8 parts. 12 parts also you can divide it. So after dividing the circle into 8 parts, so the perimeter of the circle is 82. So with the 82, so first of all you can locate in points here. This is 8, 1, 2. So with the length of the string, perimeter is 82. With that perimeter, we will draw a horizontal line. 82. And also we will draw the length of the string is 100. First of all, you can locate it. So 8 is nothing but here the perimeter of the circle 82 mm. Now we can divide this circle, this horizontal line into number of equal parts by following the divide a line method. That means from point 8 you can choose any one angle and divided this line, this 8 line into number of equal parts. Now joining 8 dash and 8. Through 8 dash and 8 we will draw the parallel lines. From the points on the inclined line we will draw the parallel lines through 8 dash and 8. And locating the points here. So they are giving that the length of the string is 100. So we can extending the length of the string. With the length of the string we can draw the length of the string. So extending another 18 mm and locating the length of the string as point P. Now from the points on the circle we will draw the tangential lines by following the each angle should be 90 degrees, so we will draw the tangential lines. So through O1 we will draw the tangential line, through O2, through O3, through O4, through O5, through O6, through O7, through O8 we will get the horizontal line. Draw the tangential lines like that from all the points on the circle. After drawing the tangential lines, measure the line length of 1 to P. Length of 1 to P. With the length of 1 to P, 1 as the center, with 1 as the center, 1P as the radius, draw the arc. Similarly, 2 to P line length, measure 2 as the center, draw the arc, measure 3 to P, 3p radii, 3 as center, draw the arc, 4 2p length measure, 4 as center, draw the arc, 5 2p measure, 5 as center, draw the arc, 6 2p radii, 6 as the center, draw the arc, 7 2p measure, 7 as the center, draw the arc, 8 2p measure, 8 2p line length, 8 as the center, draw the arc. So now we can locate in different points. So here P1, so here P2, this is point P3, this is point P4, point P5, point P6 here, point P7, so here point P8, and here we'll get the point P. So joining all the points, draw a freehand sketch. So if the length of the string is greater than the perimeter of the circle, so we'll get the involute curve like that. Free-handedly we'll joining all the points. So the circle is also make it thick. So like that we will construct the involute curve. So after drawing the involute, so we will draw the dimensioning also. So draw the dimensioning also. Here you can mention all the dimensions what you can follow. These are the construction lines we can draw very thin. So this diameter is they are giving that 26 mm, and the perimeter of the circle I am following here 82. So by using the formula pi d you can find out, and the length of the string is also they are giving that 100 mm. We can representing like that. So this is the involute of a circle. When the length of the string is greater than the circumference of the circle, we will draw the involute. So this is the last topic in the first unit. So this is about the involute of involutes.